Hi everybody, this is Chef Kristi, and today we're going to talk about chemical reactions that happen in baking and how we make those changes occur. So we're going to do some experiments that are going to involve baking powder, baking soda, and yeast. So chemical reactions during baking, those things occur when we use certain things called leaveners. So if we're making some bread, we're going to use yeast. If we are doing something with cocoa powder, say, we're going to use baking soda. And if we're making a cake or cupcakes that don't have an acidic ingredient, we're going to use baking powder. So let's start with yeast. First, with our yeast, whenever you're making bread or rolls or pizza dough, you have to use yeast. And yeast is actually a microorganism that is asleep, essentially. So when the yeast is asleep, it's freeze-dried and it's really not reacting to anything. We keep ours in the refrigerator so that it will stay fresh when we want to use it. So if we're going to bring this yeast back to life and get it to do its job in the baking, we need to do a couple of things, because what we want him to do is to get into our bread dough or our pizza dough and create gas bubbles, carbon dioxide. And those gas bubbles are what creates the rise in our bread dough or our pizza dough or our rolls. So how we do that is we are going to take our yeast and we are going to mix it into some water. It's like if you want to take a nice warm bath before you go to school and make sure that you're nice and cozy in that bath. You also want to have something for breakfast, right? So yeast really likes to eat sugar or brown sugar or honey, anything sweet like that. That's its breakfast. Once it does that, and we've got it in its warm water, and we have it in its sugar, it's going to start having a chemical reaction where it starts to produce carbon dioxide. And one of the silly things we say around here is we say that he's starting to burp. So when he's burping, because he's had such a nice big breakfast, he goes, and he makes his carbon dioxide bubbles. And that enacts the rising in the dough. So when we're doing our yeast experiment, these are the things that we need to have. So I've got a little vase, probably like a little flower vase, with a nice opening so that you can see what's going on inside and it's clear. We have some yeast. We have some sugar. And I've got some water that's between 100 and 120 degrees. So your water can't be too cold because it won't activate the yeast. And it can't be too hot because it will actually kill the yeast. So anything over 120 degrees will kill the yeast. Another thing to think about with yeast is a lot of times it has an expiration date. So you always want to make sure that it's not expired, because you'd hate to do all that work with your pizza dough and the kneading of the dough, and then nothing ever happens because your yeast is expired. So make sure you check your date as well. First thing we're going to do is put a teaspoon of sugar into our container. We're also going to put a teaspoon of yeast. This is an instant yeast into our container. And then we're going to fill it with our water. Like I said, right now it's about 106 degrees. And you can just kind of swirl it together so that it will all mix together. And then what we're going to do is we are going to watch and see what happens with this and the reaction it'll have by putting a balloon on top of it. So this balloon is going to trap in that carbon dioxide, and we'll see how much it rises. And we'll give you guys some time frame to see how long that it is going to rise. Okay, let's move on to baking soda. So once in a while, you'll see an ingredient that needs baking soda, baking powder in a recipe. But when it's just baking soda, like the way that yeast needed sugar and wanted to eat the sugar, we want to have something acidic when we're working with baking soda. So it likes things like vinegar or lemon juice to be used in the, or cocoa powder to be used in the recipe. So when we add those things to it, that is what the baking soda needs to have its chemical reaction to actually do its producing of the big carbon dioxide bubbles that make the rise happen. So we're also going to use a bottle, just like we did before. We are going to use a cup of vinegar. This is just a white vinegar, can be used for pickling, but we can also use the vinegar you can use for cleaning as well. And then we have baking soda. All right. So let's try this experiment. So first thing I'm going to do is I'm going to pour my vinegar into my jar or my bottle. And I have loaded a tablespoon of baking soda into this balloon, okay? So we're gonna see what happens. So I'm gonna take the balloon and I'm just going to put it on top. And then, are you ready? Okay, let's see what's gonna happen. Oh my goodness. That is cool. It's gonna keep going, and if it makes a mess, I'm in big trouble. Make sure if you do this at home, you've got an adult with you. This is great. I got a little nervous there for a second. I thought I was gonna make a big, big mess. So you can see when the baking soda has the acid with it, it can make a big, big mess. So a lot of times when you look at a recipe, you're gonna see that it needs like a half a teaspoon or a quarter of a teaspoon of baking soda. Obviously, you don't need a ton. We did a cup of vinegar and a tablespoon of baking soda. Don't ever put that much in something because you might get a big mess. So let's talk about baking powder. So baking powder is actually baking soda with an acid already in it, a couple other things like cornstarch in there to keep everything really dry. So it already has the acid in there, and that's why it's most often used for baking. But you might ask, what if you just use baking powder and it already has the acid in it, and there's an acidic ingredient in your recipe? Well, it might cause it to react too quickly and then mess up the structure of your cake or your baking, your cupcakes, because it rises too quickly and it kind of falls over and gets big bubbles and then they collapse in the oven. So that's not what you want to do. So let's go try the baking powder and warm water. We're not going to add anything to it. We're going to see what happens with it and the balloon. Okay, so I'm going to add a tablespoon into our jar, and just because that's the same amount that we used of the baking soda. I have warm water here, and we're just going to pop this in here. Shake it around a little bit. We've got some bubbles happening. Let's get this on here. Let's see what happens with it, because same thing's happening. You can kind of see that it's got some bubbles happening. Oops, it's making our balloon do its thing. So I've got warm water in here, and look at all those little reactions, but not as fast as the baking soda, right? Not quite. So the one thing we're missing is the heat from the oven. Okay. So we now have done the first stage of our double acting baking powder. So it's a two-stage process that happens. So first we have added the water. It was warm water, so that's why we got a little bit of reaction. the reason that we haven't gotten the big reaction like the baking soda is because we need the second stage to happen, which is the heat from the oven. So the heat from the oven mixes with the baking soda and all the other ingredients and the carbon dioxide grows very gradually, creating a really stable product without holes in it, without falling over, and it's very stable. Okay, so it's been about 10 minutes. This is the yeast, and nice, slow, steady rise. That's why we use it for bread. I can also tell you, too, that these bubbles right here, whenever a bread recipe asks you to knead it more than once, it's because you want to break this kind of stuff up and let it start creating those bubbles again. This guy really hasn't done a whole lot more. It's about at the same place that we were before. And then we remember this dude, right? It was baking soda, and that balloon just about popped off the jar right away.